Hello there, welcome back to our logistic regression demonstration. This is part 4 of 4, and I'll be showing you how to graph your interactions so you can interpret your findings in a visual way, which is really helpful when you are trying to get your results published or you need to show your dissertation committee what this relationship looks like. It's also helpful when you're just starting out with logistic regression so you really understand how these relationships look on paper. So to get you started, we can just go back to the data set real quick. And I'll show you a few variables that I added here. Now what we asked SPSS to save for us was the predicted probabilities for each of our participants of either attending treatment or not attending treatment. So anything above 0.5 was considered to be a probability towards attending treatment, and anything below would be did not attend treatment. And one of the ways that we graph these relationships is by graphing the probabilities, the predicted probabilities against some of our primary predictor variables. So to see how that looks, we can go to our chart builder again, and we'll go ahead and reset that. And I also use the line graph for this. Again, I'm sure some folks are way more creative, so feel free to change the graphing type if you want to. And again, I'm going to put gender as our color because that's just going to be easier to interpret since it's categorical variable. I'll put our center motivation to change on the x-axis as our continuous variable, and our predicted probabilities on our y-axis. And you just want to be sure always that you, under groups point ID, that you have your grouping stacking variable selected. And once you do that, you can click OK. And this should give us our graph. And what you see here on the y-axis again is the predicted probability. Anything between 0 and 1. And this is why we see our traditional S-shaped logistic curve here. And what we're seeing is that it's particularly clear for men, whereas women have a little bit of a flatter curve, is what you can see. And as we learned about the men, for each 1 point increase in their center motivation for change, their odds of attending treatment, and therefore their probabilities of attending treatment, went up more dramatically than for women who typically attended treatment just in general more often. So that gives you a really good idea of what that interaction looks like when we think about probabilities. Now, some people do find it a little bit disorienting to look at the curve of the logistic regression or the logistic function. Sometimes it's easier to kind of see the interaction when you're looking at strictly linear relationships. So to get that effect, you can go back to your graph. Well, actually, I'll show you how I made this up. Now, SPSS doesn't have a way, as far as I know, just in the regular routine to get the log odds of your outcome variable. But you can create that pretty easily as a compute syntax piece for SPSS. And that's what I did here. And I'll show you the syntax just so you can use it if you need it. Basically, all you have to do is in the compute, you can also pull that down from the menu under transform, so you can just add this equation into your compute box here if you want to. But basically all you have to do is put in your regression equation that you can discern from your parameters table. This, for example, is just our intercept from our model, and then we have our unstandardized regression coefficient times each individual's dichotomous gender variable plus the unstandardized regression coefficient for centered motivation for change times each individual centered motivation for change, and the same for the interaction term. So whichever term you put in there. And this will give you the log odds, which is going to provide a more linear look at the relationships. I've also added these really simple ways of kind of transforming amongst the different ways of considering your outcome variables. So you can also transform them to odds very easily, and also to probabilities. So that's how SPSS is looking at your probabilities. So let's go ahead and graph this as well, the log odds. And all we have to do is go back to Chart Builder, and since we already have everything in there, I'm just going to put our log odds over, oops, sorry, put our log odds, drop it in there, or I'm not going to, so I'll just I'll take that out first. And then I'll put our log odds in as our y-axis. And again, I'll hit OK. And now looking at the log odds of attending treatment, you can see we have a little bit of a clearer vision. Women in general obviously have just higher log odds of going to treatment, whereas men kind of have a wider range of log odds about whether or not they're going to attend treatment. And you can again see the steepness of the curve for men compared to women, and that's where we're really getting our interaction from. So we can kind of see that for women in general, they're more likely to attend treatment, and the incremental increases in center motivation for change makes some difference in whether or not women will present for treatment, but not as strong of a difference as it will for men. So I hope I was able to help you understand how to conduct a logistic regression in SPSS or PASWA, and or PASDUB, however you want to call it. And I hope I could also show you how to graph this interaction so you can show people exactly how that relationship looks when you're considering an interaction in a logistic regression situation. Thanks a lot for joining me, and I hope to see you again online soon.